Following is my conversation with Walid Saba. Walid is a distinct voice in the AI community with original point of views on deep machine learning and its limitations in the context of natural language processing, natural language understanding, meaning, concepts, context, and other important topics related to natural language understanding. In this conversation, we talk from philosophical all the way to engineering, practical implications and problems and their solutions and frameworks. We talk about the connection between intelligence and consciousness. We also talk about what kind of questions people, practitioners, business executives, technology executives should be asking themselves about having a diversified architecture approach to AI strategies within organizations and not put all eggs in the basket of deep ML, even though deep ML is a very powerful tool for a certain class of problems. But when it comes to natural language, we have to look at other areas as well. Walid encourages open inquiry, an interdisciplinary approach. We talk about complexity theory, Melanie Mitchell, Santa Fe Institute, and in the context of how to bring an interdisciplinary approach and complexity theory also as an extra lens to look at the AI architectures of today. And much, much more. There is a lot of advice that Walid have for practitioners. I had a lot of fun in this conversation. I found Walid to be original. I'm so looking forward to collaborating with him on many things. I hope you find this podcast, this conversation with Walid, both joyful and useful. And now here is my conversation with none other than Walid Saba. Walid, sir, how are you?
Good. How are you? Good.
Good. I'm good. I have been quite honestly for many months looking forward to connecting with you, and finally we did. So I'm so happy that we are here today, and we are going to talk about your perspective, Walid, on natural language and natural language understanding and conversational AI and how we need different kind of thinking and frameworks, and the deep ML answer is not our solution set has its limitations. So I'm so looking forward to it. But I think first thing first, maybe Walid, we start with telling the audience a little bit about, sir, you and your story. You have been at it for quite some time now. So I think it would be good for people to hear about your journey.
Okay. First, thank you for asking me to do this. I've been at it for a while. I'm an old timer when it comes to AI. I've been at it at least 30 years since even in my undergrad, I got hooked on AI in general. And I lived through the first AI winter. That's how old I am. And my passion has always been, I mean, AI in general. There are so many things that fall under AI, from knowledge representation, reasoning, to, but the real passion has always been language. Maybe because Alan Turing, the computing pioneer, chose it as the test for machine intelligence. That's what the Turing test was all about. If a machine can, if you can converse with an entity for a considerable amount of time and not realize you're conversing with a machine, then that machine is intelligent, basically. And so, and what really attracted me to language is the fact that it's a mirror to the mind, really. I mean, language and thought come together. They're if and only if. We're the only species that has this faculty. And we're the only species that can do reasoning and thinking at a level that is beyond any other species. So language, early on, I discovered, is a mirror to the mind, and it is such an interdisciplinary subject. I mean, it touches on psychology and cognitive science and linguistics and philosophy and logic and neuroscience. I mean, it's really a fascinating subject that I loved being in that interdisciplinary thing. Now, for a while, I did language research sort of solo on my own, because AI for a number of years, especially after the AI winter, was not a popular field. And back then I made a living as a software engineer. After all, I'm a computer scientist. But I never stopped doing research and reading and investigating, and because I was really obsessed with this problem. Really, the only word I can use is obsessed. And fast forward to modern day AI, which I'm happy that there was a resurgence of AI. I'm not too thrilled with how it's being sold and all the, in my opinion, misguided hype that has followed this resurgence. And yeah, I have strong views on how language understanding is being pursued now. And I keep, for a year and a half or so ago, I have started writing, because I'm reading stuff and I'm hearing stuff that is really, I mean, I don't want to use strong words, but scientifically absurd. I mean, and the confusion between language or mere text processing, really, and that's what language processing is. We're processing text as data, as opposed to the real holy grail, if you want, of language comprehension, real language understanding. And yeah, I have strong views on how NLU is being pursued now. And I've written, actually, the last post I wrote, which I've received tons of messages on it, and I'm glad it started a debate, at least.
Yes, it did.
Yeah, where I actually absolutely say machine learning, specifically deep learning, which is just a reincarnation of the neural networks of the 80s with more computing power. That's all it is. I'm saying that this approach is not only not going to do it, but it's even irrelevant to language understanding. It's not even relevant.
Yep.
We can get into details, but I outline the reasons why, and they're not opinions, they are mathematical reasons. I mean, one of them is an outright proof that this paradigm is inconsistent with the problem of language understanding.
Yep. No, we will definitely today Walid, we'll get into all of that. Maybe, Walid, a good next thing to talk about is, sir, uh, as you mentioned, languages, at least on planet Earth, looks like a
Right.
unique human trait, and only human species has it. Uh, what do you think are some of the key features of language, and where does the meaning come from? Whether you want to share some philosophy or engineering, but I always wonder, the ontological basis of meaning and stuff. And we'll in a minute talk about your company as well, Ontologic, which is an awesome name, I must say. But sir, maybe let's talk about, Walid, your thoughts on what is language and where does meaning come from, and how are we able to uh, communicate with each other as people, but not communicate with animals or ants or birds and or other octopus, that it's just a very human thing. And just and it's also in its broader sense, Walid, I always wonder, people talk about, in American popular culture, aliens, UFOs, and how would we talk to aliens if one day we run into them or their technology? I always ask this question that, okay, yeah, how would we? And there are movies on that topic, but we hardly ever attempt to talk to other fellow living beings, creatures on planet Earth. But we are so excited to talk about aliens. So I want to, uh, take a moment here and just want to hear your thoughts on language, meaning, and if one day we want to talk to, ants or fish or birds or other alien forms of life on planet Earth or elsewhere, how to even think about that?
Yeah, well, you made an interesting observation that we're more eager to talk to aliens from other galaxies than we are talking to our fellow human beings on Earth. Yeah, that's a good point. I never thought about it this way. Uh, the Yeah, I don't know if I mean, regardless of whether there's life elsewhere, I think theoretically it seems very plausible. Why should this planet have only living things? But human languages, at least, I think. Uh, I mean, well, you asked first, what is language? I mean, to me, language is a very advanced communication system. I mean, there are many other ways of communication. We can communicate with sign language. We can communicate. When I make a painting, I'm communicating. I'm expressing some thoughts that are internal, and I'm letting them out. That's one way of communicating. When we play music, we're communicating our thoughts and feelings in another expression, in another form of communication. But obviously, language is a very advanced way of communicating, and without language, we would not have preserved knowledge and incrementally add to it, and we would not obviously have progressed that much. Uh, and historically, at least, anthropologists and linguists and psycholinguists and etc. They they are in agreement, generally speaking, that language came with a real advance in our mental capacities, in our cognitive machine. Uh, Apparently, they relate that to when the earliest signs of language came together with our species, our Homo sapien line of human life. They started making tools and designing things and creating. Basically, it came with a leap in our cognitive abilities. They came together. I mean, How that happened is the million-dollar question. And but apparently at that point there was a huge advance in our brain that started this language faculty, if you want. Now, and it developed in such a way that is amazing, where we communicate in a very optimal way. We say only what is needed. We don't say anything else because we assume the rest is known to all of us, and it's common. And that's why we call it common background knowledge. And so when we communicate, we compress the full the thought we're trying to convey. There's so many things implicit in it that we don't say because I assume the listener or the reader, if I was writing, will in the decoding process or in the understanding process, they have the rest that can be filled in the uncompressing process. So it's an amazing thing that happens in language. Now, that common knowledge that we implicitly assume when we communicate is not as massive and complex as people think. Whenever we say you need common background knowledge in language understanding, people immediately assume this massive amount of knowledge that is intractable and we can't build it. And that's not true. That's one of the discoveries at least I came across. And intuitively, the proof is a 4-year-old. I mean, you can converse with a stranger, a kid that you meet in a zoo, and I've done it almost indefinitely. And she's a stranger; she doesn't know me. I don't know her, and we can communicate for hours. And that child has very little domain knowledge to speak of. I mean, they can hardly open their jacket. I mean, but apparently the knowledge you need for language is not that massive. The trick is, what is the nature of that knowledge that is needed in language to fill in the details that we don't say when we communicate, that I can safely assume you know. So, for example, if I tell a little kid that my son enjoyed the sandwich, right? She knows I mean my son enjoyed eating the sandwich.
Yeah.
I didn't have to say that. Although a kid can do many things with a sandwich. We can make a sandwich, we can throw a sandwich, we can. Why the thing that my son enjoyed about the sandwich was eating is implicit. We don't have to say it. Or if I say my son enjoyed the movie, enjoyed watching, not directing or producing the movie. So we have that rich ontological structure that helps us fill in the gaps, fill in the missing information that we don't convey. And it's a fascinating process. And I also think, and I know because I'm working on it, it's very systematic. Language is not this mysterious thing that it happened that we still don't know how it works. Some of us probably think they know now how it works, but once we know how it works, it will end up being something very systematic that is, and it's amazingly less complex than we ever thought.
Yeah, no, that is, so spot on. One thing, Walid, that I sometimes just wonder about, you were talking about the evolutionary history of Homo sapiens, and I'm not, a student of anthropology or any of that, maybe I know just a little bit to be dangerous. But it looks like that
Same here.
our neocortex developed, relatively speaking, long time ago. But people like Noam Chomsky and others think that language in evolutionary scheme is a relatively recent phenomenon for humans. And so I always wonder,
yeah, I agree.
We always had that neocortex, that big cortex, and then now apparently one area becomes the language area on the left side of the cortex. Do you have any intuitions on, what might have triggered? As you said, it's probably a rhetorical $1 billion or $1 trillion question, but any intuition on why language is a recent phenomena and that kind of a thing? Is it tied to consciousness? Is it some other emergent behavior that we were trying to experiment with tools and stuff? And I don't know. I'm interested in hearing your intuition on that.
I'm not at Chomsky in the absolute sense, but I think in this one, Chomsky was brilliant. I think that's his probably biggest contribution that I agree with, that at some point, which is not that old in terms of in the whole scheme of things. I mean, it's very recent. Recent being 200,000 years or so. People disagree on that, but roughly speaking, as opposed to millions of years of evolution. So it is recent in that sense. Yes, there was a moment that some machinery started to develop. Chomsky calls it the language faculty.
Yeah.
I think I absolutely agree with that, because there is evidence that from that moment, the human progress started to become exponential. That because now I can communicate my thoughts more efficiently, and thoughts can now be transmitted to future generations because word of mouth. So, and that led to an exponential growth in our progress as a species, as opposed to millions of years before, where it was pretty much at the same level. So now, what sparked that? Where it came from? What is the origin of that thing called the language faculty? I mean, I think a future Nobel laureate will discover how that happened. But at least the thesis that progress in that moment in history came when language and thought came together, and we wanted to convey our thoughts, and we started coming up initially with rudimentary languages, very primitive, but from there on, I mean, the rest, as they say, is history. But I agree that it's a biological thing, right? Language was not just an add-on. Like we have a visual system, which is much older, right? At some point, there was a language system that developed in our species. The origin of that, how it happened, I don't think anybody knows at this point. But obviously, we started developing thoughts, and we had the eagerness to convey it, right? And some biological accident happened that we developed that machinery to help us communicate our thoughts. So and that's related to another subject, which is innateness. There's implication, if you believe in this theory, that yes, language is biological. We have a language module, like we have a visual module, like we have a hearing module. So if you believe in that thesis that language is really a biological organ, there's a biological organ that is ready for something we call language. If you believe in that, then there's a lot of innate stuff that comes with us by birth, and language is not. And here I also agree with Chomsky, who am I to agree with Chomsky, that language cannot be learned, and that's relevant to machine learning. Language cannot be learned just from data, because it would take a child 60 years before they can do reference resolution.
Yeah.
It would take them another 60 years to resolve the issue of nominal compounds. Nominal compounds be when you describe an entity using more than one noun, like software engineering, or plastic factory, or plastic cup. A plastic factory is a factory that makes plastic. A plastic cup is a cup made of plastic. I mean, in language, there are so many things that that a child doesn't have time to hear 2 million examples for each phenomenon. They would be 90 years old before they speak. So obviously, that idea that you can learn language from data is beyond ridiculous. And that's why sometimes I'm amazed, how can blatantly unscientific stuff go without any criticism even. I don't want to say more than that, but just critique, what happened to scientific debates, and everything is accepted without any question. Although scientifically there's no plausible defense of such quantifier. You take something like quantifier scope. I mean, if I say I visited a house on every street in my neighborhood, I don't mean a house. I mean on every street in my neighborhood, I visited a house. I read it the other way because I know there cannot be a house on every street in my neighborhood. Even a 4-year-old knows that. The mechanics of how this happens, man, I would need 5 million examples just to learn that. So no, there's a lot of stuff that's innate. There's a language. There's enough that it needs just some bootstrapping. And that's why by the age of 3, when a child knows how the word works, the naive physics of the word, if you want, the naive common sense physics, like mountains don't dance, like if you leave something, if something drops from your hand, it will, I said drop, it will fall down, it will not go up. Things about the naive physical world. And once they got that, it's like the language module was ready. And it's not incremental, by the way, which also refutes the learning theory. Because it's a threshold. Once they get it, we call it the language competency. That's it. You can't stop them from talking after that. It's not an incremental thing where, by the age of 4, they know reference resolution. By the age of 10, they know how to do quantifier scope. No, it's a module that needs enough bootstrapping. And once it got enough and it came alive, that's it. It's done.
Yeah. No, that is so powerful that we as people in our early development cycle, we very quickly build the model of the world, and we keep building upon it. It looks like that we need generally very few examples to learn, and our machinery is more generalizable when it comes to learning. And you are so right that from a traditional machine learning approach, it would, it would take decades for people to learn the language. So it is that, apparatus that we come with, the faculty, as Chomsky calls it. If now, Walid, maybe we were to shift about that now, thinking in the context of AI and creating these AI beings with whom we want to talk to, and just like you and I are talking, and that to be a main modality of communication. How do we go about doing that. And suddenly we both know that deep learning and a big differentiable end-to-end network is not an answer to everything. So how do we, when it comes to natural language understanding in the context of human and machine or humans and computers, uh, unpack, I know that it's a loaded thing, but please unpack it for us in terms of how you think about it from a framework perspective, and how to understand the problem, and then any attempts to solving it, because it is certainly a very relevant topic of the
Right,
day.
right. Yeah. Well, there's a lot there, but before it's relevant to this big question, but I said language cannot be learned from just examples. That's not how a child learns language. They need enough, but there's a system with a lot of innate, especially innate ontological common sense physics. Like we come with a lot of built-in stuff. And that has something to do with the question you're asking. I think we went too extreme with the learnability thing, machine learning, deep learning. And it's understandable why everybody swallowed that without asking questions. Because the folk psychology meaning of learning took over, which is how do we become intelligent? Well, we learn.
Yeah.
So the folk meaning of learning is being misused here. And I wrote about this, that most of the things that matter, we don't learn them in the sense of machine learning. And let me start with a very simple intuitive proof. And then I'll go to, if we don't learn it, how do we acquire it, right? Learning by the machine learning paradigm is learning from observation or from experience, and the experience and the observation is usually data. So learning from data, because we codify all the experience and observations in data. So learning becomes learning from data. You ingest data and you learn from it. Well, if we learn everything from data, or if the knowledge that we possess, I don't want to say intelligence because it's a very loaded word, but the knowledge we come to possess, if it's all learned from experience and observation and data, then we're allowed to learn it differently because we all have different experiences, different. But that's not true. Most of the stuff that matters in this world, we're not allowed to learn it differently. So by counterpositive logic, it's not learnable. In other words, we don't learn, for example, that water boils at 100 degrees Celsius. It's if we learn it from observation, then you might learn it differently from me. We're not allowed to. We're not allowed to learn that the circumference of a circle is not 2 pi r. It's not up to us. Most of the stuff that's real knowledge in this world, that's relevant, right, is not learned in the machine learning sense. It's acquired. It's knowledge that is either deduced by someone like Isaac Newton, or we discover it, we stumble upon it, and this happens in science, happened many times, or we are told about it, we learn it by instruction, by those that discovered it or that deduced it, right? So, and that applies to most relevant and important knowledge. The stuff we learn is stuff that is not that relevant. That's stuff that we learn by experience. I learned to ride a bike, right? But the universe doesn't care if I know how to ride a bike or not. But the universe cares if the circumference of a circle is not 2 pi r.
Yeah.
So there's a lot of confusion because we call both of them I learned.
Yeah.
I learned that the circumference of a circle is 2 pi r, and I learned how to recognize cats or play guitar, right? We call both I learned.
And they are two very different things.
But they are two different things. And unfortunately, with this runaway train of learning, we forgot that, wait a minute, there are stuff that we don't learn from experience. We learn by deduction, by deducing them scientifically, and when we are told, so we are instructed by them, or we go and buy a book and read that fact, right? And then we learn, we acquire it. So we say I learn, but really it's not learning from experience. It's different from learning how to ride a bike, trial and error until I learn. So there's a lot of confusion on what machine learning, even if it's 100% successful, it's relevant only to one part of the knowledge we acquire.
Yeah.
The other part is not learnable. It is not approximate. It's a fact that has to be deduced, and there's no margin of error. It is not a statistical fact, right? What was the probability that the Earth is flat before we knew that it's not? It was 0.
Yeah.
It was not 50-50, even if we don't know, right? So there are things that we cannot learn with some statistical error of mark. I mean, the circumference of a circle is 2 pi r, not with degree 0.98. No.
Yeah.
Right? So there's a lot of confusion on machine learning and what it can do, even if it's completely successful. Okay, so now when it comes to general AI, I think we have, and now we have examples from self-driving cars to other examples, but that if we insist on one single paradigm, which by the way is based on a 10-line code.
Yeah.
Backpropagation.
Back stochastic gradient descent and backprop.
Right.
Yeah.
We optimize, we do stochastic gradient descent, and we optimize using the backpropagation algorithm. That's it.
That's
right?
it.
It's a paradigm that you can explain in half an hour. Everything else that happened was more computing power. That's it. These models could not process that much data back in the 80s, but it's essentially the neural networks, the PDP we used to call them. I still remember volume 1 and volume 2. The PDP models of the 80s, same model. Well, we came up with a few more, different activation functions, right?
Yeah.
And we discovered that this activation function is good in this domain, this is good, right? But all of deep learning is the neural networks of the 80s. And all the criticisms that happened back then still apply. Without getting too technical, I'm amazed that one of the most prominent cognitive scientists that I have a lot of respect for is the late Jerry Fodor. And he and Zen Pilishin in the late 80s wrote a devastating criticism of neural networks, like what it can do and what it cannot do, right? And I went back and reread that and other papers that he wrote on the same subject. And I find that criticism has not been answered up to now.
Yeah.
But people dismiss it as, who cares?
Yeah.
Let's keep doing this since everybody's excited. And what? So, but it's going to hit us in the face. And that's why I've been writing, saying, guys, some sanity, please, please. And look what happened in self-driving cars. I mean, they're crumbling one after the other because
they have run into several roadblocks. It is dawning upon people that it is a very hard
complex
problem.
Right. And 4 years back, I was still in the Bay Area. And in Silicon Valley, it's all machine learning, deep learning. Okay, fine. And a lot of good stuff came from it, but it applies in a very, very, in pattern recognition only, basically. That's where its place is. When I was, let's say 4 years ago, saying to brilliant scientists, PhD colleagues, guys, self-driving car, they were very excited. They were believing Elon Musk that it's going to be next year.
Yeah.
And back then, I told them, this is not going to do it. They were looking at me like, what? But you see the progress happening? I say, yeah, I see a lot of stuff in the media, right? A lot of, lot of big titles in the tech media. But they said, why? I said, autonomous driving. An autonomous vehicle is an autonomous robot. It's an autonomous agent that has to function in the real world where there's uncertainty and dynamic things might happen and change every second. Guys, this will face the frame problem. They say, what? I said the famous frame problem in AI that was talked about in the 60s by Hayes and McCarthy. And this will not do it. Driving is not just pattern recognition, seeing the tree and seeing the stop sign and just analyzing the data. And my 4-year-old can see the street and the stop sign. And would I give him the car? No. Driving in a real environment, unless you want like a railway driving where you can have autopilot, it's okay, we can do this tomorrow. But driving in a real environment is a very complex function that requires intuitive reasoning, default reasoning, prototype reasoning, statistical reasoning. This is not just about visual input. But back then, the runaway train was so crazy that they wouldn't listen to you. They wouldn't. Now people are starting to say, I remember you saying that. Okay, good. Although we're still not there yet. There's still some crazy stuff going on, especially with GPT-3 and which is another like farce in my opinion. I don't.
It is, very hyped up.
And I don't mind them hyping stuff in tech and commercial, in the commercial world, people hype stuff, but there's something that has gone too wild in the sense of, I mean, there should be, there should be something like, don't say stuff that is outright false. I'm not saying it's all bad intention, but probably that's what they believe. But you're trying to memorize language. Language is infinite. I mean, what you're trying to, by definition, you cannot memorize infinity. So what are you doing? So this is a long answer to AGI. For AGI, I think we have to go back to the drawing board. Not NLU. NLU is a different little part on its own. It's related, but for general AI, and people say AGI will be here in a few years. Come on. I think we have to go back to the drawing board and do a multidisciplinary. I mean, AI will require everything we know about the mind and reasoning from even before Socrates and Plato. I mean, logic and reasoning and the nature of concepts. All of that in a backpropagation machine, which is essentially a powerful tool for pattern recognition, but that's all it is, right? So there's and if we don't do that soon, I mean, now people are starting to incorporate graphs. They're calling it graph neural networks, or they're starting to talk about Symbolic AI, which is just a catch-all phrase, like let's try a little bit from each, and that's not scientific. The mind is a modular machine where we have different modules that are experts in different things. Vision, speech, analogy. There are modules that are good at reasoning. There are deduction. There are modules that are good at analogical reasoning. There are so we have to build these modules and work together from many disciplines and see how these modules will communicate and how intelligence is an emergent property of all of those. There's a lot to do before we can speak about artificial general intelligence. And I'm afraid the way we're doing it now, we're just delaying when it will happen. This will hit a wall. And hopefully we will not have another AI winter, because...
What do you think, Walid, the probability of that? Because you're so right that there is a chance of running another uh, running into a winter. We definitely, if we continue on the path that we are on, we are going to hit the wall, because there is this sort of belief that is being popularized by many, that these neural nets, they are universal modelers, and all you need is a network to be big enough, and you can configure it a little bit differently, and sparse connectivity here and recurrent here, and those type of things, and you can throw any problem at it and it will learn. So against that belief, a lot of money and media and academic and business and other interests are chasing, and there is a lot of inertia and momentum and money being spent. So what is your and think about, people think, well, when they think of AI, they say, okay, the Einsteins of AI, let's go to Jeff Hinton and Joshua Bengio and Jan LeCun, smart guys. And they, and they, right, and they will say, look, those are the gods, they're the Einsteins, and we both know what they stand, what they are preaching. But where do we go? Like, I think there is a real risk, Walid, here of eventually funding running out, and running into a brick wall and running into another AI winter.
Right. You're inciting me to
speak freely, sir. This is your
you're inciting me to press the red button. But look, I have strong feelings about this, very strong, from a moral.
I think, Walid, I think the CEO, look, our audience, Walid, is CEOs and CTOs of big companies. They don't know.
Right. I'm gonna say my mind.
But they're making policy decisions of where to spend money and whatnot. I believe, Walid, very sincerely, that they need to hear you.
Right. No, I'm gonna speak freely. Don't worry about that. Actually, that's what triggered me to start writing, and you'll be amazed what I get privately. People saying, keep it up. And these are people that are playing the game. They told me we're playing the game, and big tech giants and not so big, but in major corporations. They told me we're playing the game. What you're saying is refreshing, and I hope it will reach our superiors, because we're playing a game. I don't want to name names, but some of them told me we stopped training this thing because sometimes with more data, the performance goes down. So I felt morally and ethically I should start writing, because I know scientifically what I'm reading and what's being perpetuated is wrong, scientifically, theoretically, technically, even from a plausibility standpoint. And there's a dangerous part, other than hitting an AI winter and hampering progress again for another 10 years, just because few people like stardom and like the big checks they're getting, and I know some of them are getting. And I could have played the game. I have colleagues of mine telling me, Walid, deep learning more than the founders of deep learning, because to criticize something very well, you have to know it upside down. And I played with it. I could have played the game and received all those notoriety and fame, but I can't. I'm not that type of person. And I started writing because I want this to reach the CEOs, the decision makers. I want this to reach the academic people. I mean, academia have been hijacked even. A friend of mine, his son wants to do graduate studies. He can't find someone to do graduate studies if you don't do it in deep learning.
Yeah.
This is immoral. This will hamper science. Like, what happened to modal logic? What happened to possibility and necessity, and how do we model uncertainty? My God, we're gonna go back and do this. Why are we wasting 20 years? Now in university, if you don't do deep learning, you're told no graduate studies for you.
Yeah.
What if I want to investigate cognitive linguistics? My God, it's like
tough luck.
No, there are language models and BERT and Bertology. What? This is the only paradigm on earth? And so it's immoral from a standpoint of hampering science. It's been hijacked by hype and commercialism.
Yeah.
The so-called godfathers of deep learning are, I don't want to say, I mean, I'm going to assume they have good intentions, but they know a lot of stuff that they're saying is false. I mean, they're all brilliant scientists. Uh, Jeff Hinton said a while back, deep learning will soon be able to do everything. Come on. I just wrote an article refuting the paper came out in a journal that I used to respect. I still respect, but they shouldn't have published this paper. Reward is enough. What? Maximizing a reward is all you need for intelligence? This is okay for animals that want to eat and have shelter. This is, yes, we maximize the reward where the reward is, I want to feed hunger. The reward is finding food. So, okay. But a lot of intelligence has nothing to do with maximizing the reward because there is not even a well-defined goal. So if there's no goal, how do you score if you're improving towards that goal? This is unscientific. And I gave an example to refute that whole thing. But the point is, I mean, like, we don't always maximize an objective function, right? I mean, I smoke. What my objective is to die of cancer, right? I mean, the human mind is so complex. It's not just about animal instinct and learning how to get food by maximizing reward. It might apply a few places. The point I'm saying is there's a lot of, in one of my articles, I say the good, the bad, and the ugly. There's some good, but there's a lot of bad, and there's a lot more ugly. Really, I live and breathe AI. It's a passion of my life, and that's why I felt I should start writing about this. There's a lot of money being wasted that I know will go down the drain.
It is. That is a very, very true statement, Walid. Walid,
In autonomous driving, billions have been spent.
Oh,
if you see how much is being spent on the machine learning approach to language, billions, literally. Yeah. And I know all of that will be put on the shelf somewhere in a museum. It will not be used at all. So people have to start to listen to, there's a young generation that is jumping on the bandwagon and believing in gods. And when you believe in gods, you become a disciple, and disciples become little gods. So it's a bad situation.
Yeah.
I told you you're gonna let me go on this because I feel very passionate, really.
No, this comes across very loud and clear. So today, companies, Walid, who want to set up their, they want to think about AI or AI strategies, what type of problems it can solve and how to solve it. What is your advice for business and technology executives as to how they should think about the strategy and architecting these new capabilities within their companies, where the popular advice is deep supervised learning? That is what the students, the employees, the tech companies, the universities, everybody's teaching them, you just got to do deep supervised learning and life would be good. What is your advice for business and technology executives? Right. Where do they go? What do they do?
Right. Look, I'll tell you what red flags are to avoid them.
Okay.
And then I have suggestions on what to do. The red flags, the big no that should come first is if your entire strategy is devoid of any multidisciplinary aspect to it, then you know you're doing something wrong. No intelligence system will be built just from one little paradigm. Bayesian statistics will explain the universe. No, obviously, this person has little knowledge, and little knowledge is dangerous. This might be a useful thing in one little module in our huge system, right? But so if you have a Bayesian, hardcore Bayesian, and I see the whole word in one formula, Bayes formula, then obviously that's not a smart dude. I will change them, right? If the whole word is backpropagation and machine learning, then obviously you're wasting your time and your money. So the red flags are, if you don't see multidisciplinary teams doing AI, an ontologist, a cognitive linguist, a cognitive psychologist, a software engineer that knows a little bit about language and AI programming. So if you don't have this, because AI is multidisciplinary, our mind is not just actually we don't even have backpropagation in our mind. But so that would be a red flag for me. I've seen AI departments where they did magic. It's usually a multidisciplinary team. So that would be a red flag for me, that these are cultists, these are religious zealots, and they're gonna take my money and throw it down the drain. That would be a red flag for me. Now, what to do? I think they have to accept the fact that this thing is very complex, and try to live with incremental change. Like anyone that's promising, oh, just give us some time. If we process trillion more gigabytes of data and you give me 10,000 more clusters of GPUs, then we'll get there. Then you're doing something. This is not how. Occam's razor. The simplest explanation is the correct one. Whenever someone tries to complicate things and put more money on it, hardware and data and time, because time is also money, then they don't have a solution. Like Einstein used to say, if you can't explain it very simply to a child, then you don't really understand it. And this is happening, by the way, when you read these papers in the literature, which have become like a factory of publications. It's unbelievable, but although it's a side point, but back in the days when real publishing mattered, you were so proud that you got a paper or two this year in a respectable conference.
Yeah.
Now you see the same person publishing 6 papers in one conference. Like, what? You have 6 brilliant ideas that will change the world. 6 in one event. Anyway, yeah, I would have to accept that in AI, progress will be in steps. It's a very difficult problem. AI is not a single formula or a single algorithm. AI is very complex. Make multidisciplinary teams, bring people that are not cultists and they're so hardwired on one hero or one approach. That's a dead end. You're going nowhere with that. I think and also there's this bashing of the old approaches, which is, I read a nice paper in AI magazine a while back that really explains why this unfair bashing of symbolic AI, or they call it GoFi, good old-fashioned AI, or the old school, whatever the label is, which is not true at all, actually. First of all, those what they call symbolic AI was in the beginning of AI. That you can't blame those guys. They were discovering what the hell is going on. I mean, they had to learn how difficult the thing is. We were just starting out, and the computing power they had is laughable. I mean, I remember 640K RAM, 64 even, right? And they were trying to discover what the hell is going on. So you can't 20 years, the AI field started and people didn't find the answer to the human mind in 20 years, that means all you did is wrong. That's silly. This is one of the most difficult problems on earth. And if those poor guys didn't solve it in 20 years, we refuse everything they ever came up with. That's silly. So there's a lot of things that can be fixed. But first, some sane voices have to start speaking, not just to bash something, but scientifically say, okay, this is good for you here, but it's not good here for these reasons. Because the amount of money and the focus everywhere in the big tech, in academia, in startups, that is a lot of waste of time and money without allowing another point of view to enter the I mean, what happened to the old competition is good because, but you have to give it a chance also, right?
That is so true. On the interdisciplinary point, Walid, do you think that do you see merit in studying complexity theory, self-organizing systems, learning from, emergent behaviors and those types of things? What is your thought on, folks like Melanie Mitchell at Santa Fe Institute and the whole science of complexity, which is a interdisciplinary study. Anyways.
That's the way to go. That's the way to go. And we need more of that. Actually, I read her stuff. And I have to thank her. I don't know if it's going to stay in public, but I saw her tweeting my latest article that says machine learning won't solve natural language understanding. She tweeted it with positive remarks. So thank you. No, I admire that line of thinking and work. That's what should happen. I mean, you want to bring. There's a lot of good stuff that went on in AI. You mentioned complexity theory, cellular automata. I mean, there's so many ideas here and there, and if you synthesize the good from each, something will come together. I mean, but to kill everything that happened. I mean, I asked people in the Valley, like they were doing NLP, right? Okay, and they are experts in NLP. And I mentioned things like, first I mentioned issues in language. They say, what? Right? You don't know what metonymy is, no metaphor. Okay, no problem. So I mentioned giants that studied language for millennia, not centuries. And they say, who? Like, and I made I was invited. I gave a talk in MIT a few years back. There was a big event, and I made a joke when I'm speaking that an NLP expert that never heard of Montague, for example, Richard Montague, or Frege, or Bertrand Russell, is like an expert physicist who never heard of Isaac Newton, or an expert physicist who never heard of Albert Einstein. Like, and it's literally the same. The analogy holds. Like, what do you mean you're a language expert, you're a language engineer, and you don't know what the most brilliant minds that studied language, you don't know who they are even. Because for them, it became, I'm doing NLP if I use a TensorFlow library or a PyTorch, whatever you're doing. And I get these already trained language models, and I, in the end, build my network with a couple of activation functions. That's NLP. So we are in a bad state of affairs. I might sound negative, but no, I'm the ultimate optimist. I mean, I'm saying that to correct where things are, because we've already wasted, I think, 10 years and billions of dollars. And we're ruining a generation of young scientists that we could have had brilliant stuff come out of them, but they were trained in one way and they think they're doing AI, but really they're doing computational statistics.
That is so true. Computational statistics and big data.
Right.
Let's maybe go into, for a few minutes, the direction of GPT-3 and GPT-4 and these popular statistical language models that are working on some large weight space, large parameters. So today, the type of colleagues that you mentioned, the natural language experts, today the current state of the art is take a pretty big sort of corpus of data, use something like self-supervised learning so that you don't have to do too much labeling, annotation, because it's costly. Yeah, you can just take existing text and create blanks in that. So you just remove words from the current language, and that is your labeling. You are going to teach a network to learn how to fill those blanks on a very large body of data and a very large model. And now that is going to learn language and all that, all that good stuff. And so there is a lot of work right now happening, GPT-3 like work, coming up with future models of, 500 billion parameters, 1 trillion parameters, computational statistics. It would be awesome, Walid, for you to kind of share with people that why that wouldn't solve the language understanding problem or context or meaning, concepts, those types of things. Here, people think that if I can just generate plausible text and we can keep going, life is good, and that kind of a thing. So that is today, there are billions of dollars chasing that, and the best brains today who are working on that, this is exactly what they're doing: self-supervised learning and generating these models. So I think it would be good for you to offer your critical input that while these models with some prompt engineering can be successful at some tasks, from a broader, bigger NLU perspective, they are bound to run into issues in real life situations. So I think it would be really good for you to share with audience your views on this very topic.
Yep. Well, why? One word, and I'll backtrack and I'll explain what I mean. One word will be infinity. That's why. So let me explain first, and what do I mean by why infinity is an issue. Look, natural language, we know, if trained computer scientists in the theory of computation, they know what computation is all about. They know that in the hierarchy of languages, formal languages like programming languages are a much simpler class of languages than natural language, right? So take a programming language like Python or Java or any one of your favorite programming languages. Can machine learning learn how to check, forget the semantics, which is a difficult problem. Can machine learning learn how to check the syntax of a Python compiler? There is no shortage of examples, so data exists. I mean, you go on GitHub and you can find 100 million Python programs. So we can give them 100 million valid Python programs and then do some permutations on the code and they become not valid. And can a deep network learn how to accept syntactically a valid Python program? No. The reason is infinity. Now, what do I mean? And I'm talking technical here. Technically, this is impossible, right? Unless someone wants to tell me that they can chase infinity. And when I mention this, people misunderstand what do I mean by infinite. They say, well, we have a finite life. We don't write an infinite number of programs, or we don't say an infinite number, or we don't hear an infinite number of sentences. That's not where infinity is. Here's where infinity is. A Python compiler, when we do it, and this goes back to logic and formal languages, formal automata, and that's why the most penetrating minds in logic were not wasting time. I'm sorry, Jeff Hinton, these were brilliant people. You cannot ignore what they did. A Python compiler is ready for how many how many programs that are valid? Infinite.
Yeah.
It might never, it will never, definitely, by definition, it will never compile an infinite number of programs, but it has to be ready for any. Any here is infinity. A Python compiler will never go back and say, sorry, but this one is not in my hash table, I cannot interpret. And this infinity comes from recursion and logical definitions, right? Same with natural language. A trillion, 2 billion trillions, right? Over infinity is 0. So you haven't really learned language. You cannot memorize an infinite object, right? By definition, like if you want to ignore science, then it's up to you. Now, can they do something useful in some context? Probably, right? And but in the end, GPT-3 is a massive fuzzy information retrieval machine.
Yeah.
It memorized millions of patterns, right? And so when you give it a prompt, and I tested it, I had the chance to test it with a few friends. And so it memorized millions and millions of patterns. And when you give it a prompt, it is good at doing similarity, obviously using for similarity, and it can say, oh, okay, you're talking about, this is the stuff that's related that I saw before that's related to what you're telling me. And it retrieves, it fetches related stuff. It's an impressive engineering exercise, but it has nothing to do with language understanding. I'm sorry. It doesn't understand. And the word understanding should not even be in any paragraph with GPT-3. There's no understanding. It's a massive, like I said, hash table and information retrieval machine that it memorized. The more practical question is, can it do something useful?
Yeah.
In some limited domains, maybe. It can be a powerful information retrieval machine, right? But it can't do, like, for example, I have an ontologik. I have barely 5,000 lines of Python code, and I can do semantic search, semantic retrieval based on topics, not keywords. So, yeah, but if I want to just build an information retrieval machine, I wouldn't spend $10 billion. If someone wants to give me 10 billion, I'll do semantic search beyond it. So it can do something, but is it anywhere near as valuable as the money spent on it? No way, not even close. If you put that much effort on a more foundational approach, you will have something. I mean, I can literally prove it. So it's my issue is we love this hammer called deep learning.
Yeah.
And I want to do everything with it because I just love it. And I love the godfathers of this hammer, and all the media supports me and they say I'm doing great stuff. So I'm going to keep doing it with this hammer. I'm going to get to a point where I'm going to use this hammer to open the door. I would just keep dumping money. No. So my issue is not exploring these because it's always fun to see how far something can go in science, right? But when hacking and engineering takes over science, you are doing something wrong. No. We explore and experiment if we don't have scientific proof to the contrary, because we still don't know if or if not. But if we know if not scientifically, then we're just wasting money knowingly. Right?
Yeah, so true. I think Walid, is a good segue into tell us a little about ontologic and what you guys, you and your team, what you are doing at Ontologic, what its mission is, and how you are thinking about things differently. So I think the audience will benefit from learning a little bit about the mission of Ontologic.
Yeah, I mean, the word mission is a big word. About a year and a half, it's coming close to 2 years now, less, year and few, 7, 8 months. I have been thinking about this for a while, but upon the advice of ex-colleagues and friends that I respect and admire, and who they know firsthand of the stuff I've been working on for several years, alone, literally alone, after hours, when the whole universe is asleep. They told me, Walid, we know you have some really good stuff there, and it seems that it will do something revolutionary in NLU. Why don't you do it? And I said, well, it's hard, and this happened, now you can't approach anyone if you're not doing it with language models and Bertology. I call all of those approaches Bertology. So no one will listen to you, or no one will support you, or no one will. And then I thought about it very hard, and I said, you know what, I'm gonna bet on myself. So basically, I've been investing in myself. I've been working on it alone. It's a system that I've worked on for over 20 years, really, with a lot of eureka moments, until I got to a point where I was like, wow, I think I got something here. And it's not an intuition, it's science. I tried the system that I came up with on all the challenges, the well-known challenges in language understanding, like lexical ambiguity, reference resolution, metaphor, metonymy. There are well-known quantifier, scope ambiguity, the problem of prepositional phrase attachment. Where does this phrase attach to? All the well-known difficult problems in language. The system started to solve them one by one. I tried it on some well-known semantic riddles, like one of them, I'll just mention one of them, which intrigued me for a while, is known as the adjective ordering restriction mystery, they used to call it. And essentially the problem is, when we have more than one adjective, why do we seem to always order them in such a way that is universal? Actually, it's even language agnostic. In all languages, it just seems natural to order them this way, not this way, even by a 4-year-old. They're all adjectives. There's no rule in the language about this. So it intrigued me, because it told me if I figure out how this is happening and why, then it tells me something about the internal language, not English or Chinese, but what Jerry Fodor calls the language of thought, or mentalese, or the I language, the internal language. And again, it solved that puzzle. So to make a long story short, I thought, okay, initially I'll do the NLP stuff. And in 8-9 months, I developed the whole stack, what we call downstream NLP tasks, like summarization, sentiment analysis, topic extraction, identifying all the key entities and their semantic type, tagging, semantic search, all the stack. And actually, I put a demo online, which attracted few paying clients that at least helped me survive this tough period. But the more ambitious goal is true language understanding, which will result in real question answering, so you can query your database in plain English, or do the reverse, read text and build relational structures from what you understood. that you can now query. By the way, this reminds me, they keep saying, putting these benchmarks and defining their own benchmarks, and they beat their own benchmarks.
Yeah.
And everybody claps for everybody, and you say great stuff about my paper, and I say great stuff about your paper. So we're both happy. I always said, why do you guys make it difficult? And it's like, it's very complex to evaluate. No, it's not complex to evaluate. Here's a test before you say we have technology that understands language. It's very simple. Put a database for some domain. I don't know, maybe a database about geography, right? Rivers and mountains, or what countries, what borders what, and what's the biggest city in this country, or whatever. Geography, any data, or tourism in South America. And allow people to query it in plain language. It's very simple. Yeah. Nobody now can even start thinking about what they will do with that, because they are retrieval-based language.
Yeah.
The same with the chatbot industry that tries to answer a question by retrieving relevant information.
Yeah.
This is the search paradigm. This is not language understanding.
Yeah.
So that's what we're doing. And as we speak, I'm trying to get some support or try to develop the full NLU that I believe is the answer that I found out over 20 years of work. I either do it with some visionary company that wants to explore that, I can do it with them, or to seek funding to develop that. So far, I'm self-funded. Few companies that tried the demo online like what I have, they want to use the API. That's where I am now. That's ontologik.
So, Walid, on that note, if people, teams, or companies want to get hold of you, do they just go to your website, or what would be your advice to people who want to get in touch with you?
Yeah, there's my email at my website. There's a contact form also, but there's also a demo website where they can register and they can write in the comment anything. There's no, I'm online. I'm on LinkedIn. People, if they want,
people can find you.
Right, even on ontologik, they can fill out the form and send me a message. And yeah, if anyone is interested in pursuing the real NLU, it just now is a matter of development. And I have so many fingers and there are so many hours in the day, so I need support, and that means money. But the technology is mind-boggling. I can go through the technical stuff with them even. But like I said, I tried it on all the well-known problems. There were several eureka moments. The last one was the difficult problem of nominal compounds, which also fell out of the system. So if anyone is interested, I'll be more than happy.
No, that'd be great. I'm sure people will. A couple more questions, and you have been so gracious with your time. For learners of today, and I know that we have been using that term quite a bit, what is your advice, Walid, as to what kind of materials they should study, or books, or approaches, or people to follow? So if you want to give anyone who is learning, who wants to learn about it, and they already have learned ML, but now they want to go to the next level in their evolution, what is your advice for all those people out there on this journey?
Right. Excellent question. You'll be surprised how many young people send me messages like this. Like, I read your stuff. I'm 100% convinced I'm not doing NLP. I'm just doing ML. But where do I start? Like, especially when I talk about things like intention and the phenomena that must be resolved in language that they never heard of. I mean, let alone they don't tackle it. So they asked me like, okay, where do I start? You know, can you give me like a roadmap? And it's such a tough question because I'm trying to summarize 25 to 30 years of my journey. And because the subject is so interdisciplinary, like where do I say, go read the philosophy of language, or go read cognitive linguistics? I mean, each one of them is a huge library. But that doesn't mean it's, no, that I would suggest work backwards. Like, okay, there are well-known problems in language, right? Lexical disambiguation, okay? Identifying the meaning of a word in a context, okay? This is a well-known problem. It goes under also WSD, word sense disambiguation. So that's one challenging issue in language. Go and start investigating how different approaches to WSD were done. What are the key techniques to do word sense disambiguation, right? Take another problem like compound nominals, like why is a plastic cup a cup made of plastic, but a plastic factory is not a factory made of plastic. It's a factory that produces plastic. This is another well-known problem called compound nominals. And dig deep and see what are the different approaches. And then you start creating this network of references to references to references. That's the best way, because if you want to do it top down, it's like, okay, what do I start with? I read philosophy first, and then it's an ocean of, but if you do it bottom up, like take all the problems, see how they were approached, it will lead you there in the end. Both of them will do the same thing in the end, but at least it's more directed and goal oriented. Like, okay, these are the challenges in language. How were they approached differently by different techniques? Because if you take, for example, word sense disambiguation, there were approaches that have roots and bases in psychology, with the idea of semantic priming, and there were approaches that came straight out of logic and knowledge representation and ontology. So that go this way, these are the well-known problems in language. What are the main techniques? And then the branches will take you all over the place.
No, that I think that's an awesome suggestion. My very last question, Walid, for you today is, when it comes to intelligence and consciousness, which also human consciousness seems to be, have a unique flavor, or at least we as people, we as humans, we think so. What relationship you see between intelligence and consciousness, language and consciousness? Are these emergent properties? And I know we can talk for hours just for this. So, and it's a loaded rhetorical question, but just would love to hear your final words of wisdom on consciousness, intelligence, language, how they all come about. It is just one emergent phenomenon and different aspects of it. I think that'd be a great way to conclude such a wonderful conversation today.
Yeah, I might disappoint here, but hopefully not. I mean, I claim I know a thing or two about language, but when it comes to even intelligence, and consciousness is another huge thing, because it's the ultimate meta knowledge about knowledge, is knowing who you are, which is a reflective thing that I'll get to that. But even intelligence, I mean, I don't think we have a fixed definition of intelligence, because people now think Elon Musk is intelligent because we equate, probably not everybody, I don't want to generalize, but for the most part, we equate wealth with intelligence. So he's intelligent because he managed to, succeed in business and make tons of money. So is Oprah Winfrey. She's intelligent because look what she did. Maybe in today's, with today's metrics of what intelligence is, Albert Einstein, for many of us, is not intelligent because look at his clothes, look at his house. I mean, the guy couldn't afford a nice car. How could that be intelligent? So, okay, I'm probably exaggerating, but because I want to drive the point that intelligence is, I mean, I know many people that live a unique life to stand by principles or to enjoy life the simple way they like it. And for many people, they're not intelligent. Actually, for many people, they were probably stupid, right? So I don't know, because, I mean, intelligence and rationality are not the same. I mean, we're not rational beings, by the way. We're rational in the sense that we can rationalize. We can, but we don't always do. I mean,
Yeah.
we do many irrational stuff, obviously. So it's very hard for me to, unless we want to circumscribe the definition and say computational intelligence in the sense of solving a problem efficiently, intelligently, with limited resources, blah, blah, blah. Unless we want to, circumscribe it in an engineering perspective, computation, then we're not talking about human-like intelligence.
Yeah.
Human-like intelligence is very, very, I can't claim to have any definition of it. And there are even issues of, is intelligence generalization? Is it being good at doing analogical reasoning and adapting to new situation using historical stuff? Maybe all of the above, and then some that we don't know, right? So it's a question that I definitely don't have an answer for. Can we get there? I'm a scientific materialist, so I subscribe to the school that we can. Although I think it will turn out to be a lot more. It will require. I think the late John McCarthy said something like this. It will turn out that we will get there when we discover a lot of new things that we don't even know about yet.
Yeah.
That they're not even in our vocabulary yet. There are things that, consciousness is another thing, and here I have doubt we will have conscious machines because of Gödel's incompleteness theorem that we will never have a computational or a formal language, which is what you need for anything computational. Nothing computational, no formal system that's rich enough to be of any use can be complete. It will be sound, which is what we care about, that's fine. But it cannot be complete, meaning what? Meaning there will always be things in that system that are true, but we cannot derive. It translates intuitively to what? In human language, we will never know ourselves fully. No machine can know itself. This needs self-reflection. We will never fully understand ourselves. So, and that's what consciousness is. You're aware of who you are and what you are. So there's a computational limitation to that we can have machine consciousness, at least theoretically, unless we discover something at the scale of relativity theory or something new in science that we don't know yet. But from what we know, computational consciousness, at least computationally, is very questionable.
No, that is so cool. Who are really some of the people that have influenced your thinking? Any notable? Certainly, probably too many people to be named, but
Right.
any few people who you would like to mention who
Not
have
not necessarily academically. We're talking in
no,
general.
in
Oh,
general, people who have influenced and shaped your thinking.
Mahatma Gandhi probably will be number one on the list. Number two would be one of his disciples, if you are Martin Luther King. These are two people that I admire a lot. They have they exemplified what humanity
Yeah.
is. And there are many. I mean, I think, but there are some in
Yeah.
the ancient history that were amazing personalities, but I admire them for different things, like Alexander the Great was the first globalist or internationalist. He had many vices, of course, but one thing was amazing for me, that someone, maybe because he was the student of Aristotle, but he was the first internationalist or globalist. Like he wanted to mix races, and so to get rid of this barrier that we're different people. And he even named Alexandria in Egypt as one of the major cities after him, saying it doesn't have to be Greek. So he was a visionary in that sense. There are many people that did great stuff in this world, but my biggest heroes will be Gandhi and Martin Luther King, and probably Nelson Mandela, people like that.
This is an awesome place to finish our conversation, Walid. Thank you, sir, for being so generous with your time. I know I had a blast, and the audience is going to love it. So
I hope I had something useful to say, and I might have sound too passionate at some point, but I feel, because I do feel I am passionate about AI, and I hope it will be done right and we don't waste too many resources.